Hi there, I'm Alan from Lads Game Studio. Today, I'm going to talk about a method of programming AI navigation using a node-based system. If you know anything about linked lists or similar data structures, some of this will probably seem familiar, but if not, it's all good. So, what is a node-based navigation system? A node-based navigation system relies on different defined points in an area called nodes that give the AIs a location to move to or through on their path. A map in a game of a scale that we're making currently would have tons of nodes, but for this video I've started with just a small sample. The path the AI will take is determined by an algorithm that finds the best path from the starting point, the AI's location, to the target location. This means that the nodes need to know who their neighbors are, so that from one node to the other we can find a path through these connected nodes. In using more regular technical terms, this is usually called something like a depth-first search. This is because we start this algorithm by going as far as we are needing to the player's position, and then working backwards to find the best path back to the current position. Now that we know more about what's going on, let's check it out in Unity. The first thing that I've done here is setting up my scripts for each of the main parts of the system. I've made a new AI script that will be attached to the enemy that's moving with the nodes, a node system script to handle all the overall map of nodes and generating the paths, and a script for the nodes themselves. Right away, I have my singleton set up for my node system, so anything will be able to use its functions, and I also make a public list to hold all the nodes that will exist, so they can add themselves on the start. In my node script, I get the position of itself and also a list of other nodes for connections. Then I go ahead to start making some nodes in place on the map. Now, in my new AI script, I'm starting the process for finding a new path and finding the nodes that are closest to the AI and the player. I will say up front too that this is my first pass on doing this for this project. I'm sure there's plenty of room for improvement in terms of optimization here, and I'll be coming back to this again and again. So, I'm storing the starting and ending nodes that are required for our algorithm to make a path, and then going ahead to make the function that is going to make the path. Then the path the function returns can be stored in the AI's current path variable. Now for our algorithm, we are starting the process at the endpoint and then working backwards. So we add the end node first, and then we want to search until the start node is in the list. We're going to check the distance between the start node we've given and each connected node from the node that was just added. Then, before we return the list, we need to reverse it so it's actually in the right order. And as it goes in programming, it did not work on the first try. And that was because the scripts were not running in the right order, so things were ending up null. But then Unity was hanging, so I spent a considerable amount of time debugging. It ended up being an issue that the algorithm was just going back and forth between nodes, so by checking if we've already got that node, we can avoid that issue. and I went ahead and made a very simple and temporary coroutine to move the AI to each node in its path. But then I got stuck again. It ended up being because I forgot to change the comparison distance while checking the distance between the start node and the connected nodes. A very silly mistake that resulted in a null node being added to the list, and the algorithm can't check the connections of a node that doesn't exist. And with that, we finally got a guy who can move on a path. Thank you for watching. If you'd like to show your support, subscribe to our channel to see more game development topics like this and more, as well as some progress on our current project as time goes on. If you're really into showing support in other sorts of ways, follow us on Twitter, or even check out our first and only release title, Crisp's Charging Challenge on Steam. And that's all for now, lads.